Okay, so for this video here, what we're going to do is that we're going to be talking about page 54b. Let's read through the question first. We have given a quadratic function fx is equal to x squared plus 4x plus 3, right? So I already drew this equation using decimals.com, and this is how the graph looks like. And we know that this is called a domain, right? Domain is in between a minus 1 and a. Because we do not know what a's value is, that's why we have to analyze a value from the left to the right. When I say left to the right is that when you look at the graph over here, right? The left and right, we're using the vertex, in this case, the right lines of a symmetry over here, which is x equal to -2. So my vertex, what is my vertex in this case, dude? Is -2 and 1. As you can see that over here, this is the vertex. The vertex also is my minimum value, right? So over here. But because my x domain in between a minus 1 and a, which means that with different a value, I should have different minimum value, right? So let's say, for example, if my domain is on the left side, which is a is going to be smaller than, well, smaller than -2. And Jonathan wanted to talk to you. Thank you, Jonathan. Thank you, sir. So let's say if my a is less than -2, in this case, negative 2.1, okay? Right here. What can you tell? Where's my minimum point? My minimum point is at when x is equal to a, right? Is it the vertex? No, it's actually right over here, right? However, if my a is bigger than -2, but also a minus 1 is smaller than -2, so basically in between. Watch this, okay? As soon as my a hits this point, where's my minimum point now? The vertex, right? And then as you can see that this will continue to happen. The minimum is continue going to be here until what? Until my a minus 1 is bigger than -2, which means that until my left side extreme, a minus 1, is equal or bigger than that. Okay, so what happens later on? Up until this point, still the minimum point is the vertex. But if it's on the right side now, where's my minimum point? Right here. So in this question here, what we're trying to analyze is that we're not trying analyzing x, because x is there. What we're trying to analyze is a minus 1 and a. What's the difference between them? And what kind of scenarios would I have so I have different types of minimum point. So for the first scenario here, when a is smaller than -2, what does that mean? It means from the graph here, right? Let's use the graph one more time. For this general scenario here, if we're using a graph, is when a, which means the right side extreme of the domain, is smaller than the axis of asymptote, right? Sorry, the axis of symmetry, right? So the axis of symmetry, x equal to -2 is the axis of symmetry. Do you know what an axis of symmetry is? Okay. Axis of symmetry is basically when you change this form into the vertex form. And in a nutshell, is the line that split this graph into half. Did you see that this line actually split the graph into half? And they're like the same. They're mirroring each other, right? That's called the axis of symmetry. Make sense? Do you know what is it in Mandarin? Let's search it up. Axis of symmetry in Chinese. I think so. Oh, there we go. 对称轴. Okay. Makes sense now. So 对称轴 basically means that, well, it's half of that, right? Okay, let's go back to scenario number 1. So do you understand why the minimum value for scenario number 1, when the right side extreme is less than -2, which is the axis of symmetry, is equal to this? Because based on this graph, what I can tell is that the minimum point is going to be on the right side extreme of the domain, which means that whatever a value is, right, over here, that's going to be a minimum. Because x is in between a minus 1 and a. In this range over here, as long as my a is smaller than -2, right? It can be anywhere. It can be here, right? Because in this case, the a is still what? Smaller than -2, right? And it's going to be always on the right side because how the graph looks like, it's going to be on the right side of this extreme, which means that it's going to be when a is equal to x or x equal to a. That's why it's substituting over here a into the equation. So once that's the case, the minimum point is a squared plus 4a plus 3. Any questions for this? Okay, you understand? Fully? Good. Okay, now, second scenario over here, okay? Which is when a minus 1 smaller or equal to -2, smaller or equal to 8. How come before this is a minus 1 and x is in the middle and a is on the right side, but this case is -2 here? So let me use the graph to understand this, okay? This is when when this is happening. Okay, watch this, okay? Exactly when on the right side of this extreme hits the -2, where's my minimum point? Is it a vertex, right? Continue, see this developing, moving to the right side, up until my left side extreme, which is the a minus 1 is equal to -2 now, right? For the whole period from here all the way till here, where's my minimum? My minimum point is my vertex, right? So that's how you evaluate here, and that's how you analyze here as well. So for the second scenario, any questions? Any questions? No? How do we get a minus 1 smaller or equal to -2 and -2 smaller or equal to a? This is actually from this over here, right? You learned from the inequalities before, right? So how do we do that? Again, we take it apart. Basically, we take this part to be here, right? And this part to be here, okay? And we simplify it, so we will get when a is in between -1 and -2. So first you gotta understand, you have to establish this equation, the inequality first. You have to establish this inequality first to understand that, okay, my right side extreme of my domain is bigger or equal to -2, which is my axis of symmetry. Then my left side extreme, my left extreme from my domain is smaller than my axis of symmetry. Okay, that's in between the graph here that we just showed, right? Good. In this case over here, the minimum value is going to be the axis of symmetry. When you substitute the axis of symmetry into it, you will get x is equal to -1. Okay, so this is your vertex. So basically, this one is your vertex. Okay. All right. Last but not least, without looking at it, what do you think? Because we already evaluated. Let's do this. So if we're not looking at it, the last scenario, based on my evaluation, you see that we did it from the left side, the right side extreme in between. Now what happened? We're evaluating when the left side extreme, which is the a minus 1, is bigger than the -2, which means that my domain happens on the right side of my axis of symmetry now. Okay, so watch this happening, okay? From here, right, that's my first scenario. My minimum points on the right side extreme, which is when x is equal to 8, right? And this whole thing up until here, my minimum point become my vertex, still vertex, 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 up until this point now, when, hey, there we go. When my left side extreme, which is a minus 1, started to be bigger than the -2 now, right? Where is my minimum point now, dude? Where is it? On the left side, okay? On the left side. And what do we substitute this? What's the value that we substitute over here? X equal to a minus 1. So all we need to do is just to substitute a minus 1 into the equation. and we will get the minimum value for this scenario here. So that explains why for this third scenario, our minimum point is over here, which is also when you substitute x equal to a minus 1 into that. Okay, as you can see that this one is for that, right? And then in between, this is just the vertex. All right, any questions for this? No, you good? All right, can you try fixing this yourself? And also try doing this yourself as well. So let's try this one first, okay? And then after you're done 54A, try 54B as well, okay? Any questions, please let me know.